All right. Well, it's good to see everybody. So our plan today, we're just going to go ahead and talk about the review, getting ready for the exam tomorrow. Okay. So remember, the exam is going to cover primarily systems of inequalities as well as solving 3x3 systems. There will be a few 2x2 systems on there, but primarily it's going to be those two items. So hopefully you're looking ahead to this, even more so, hopefully you've already started looking at the review. We're only going to go ahead and do a few of the problems today together, and then I'm going to go ahead and turn you loose and let you go ahead and work on that. So I won't be posting the key for it until after the end of the school day. Hello, hello, hello. All in. Okay, now tomorrow, I think most people in here are going to be taking the TSI for English. That's going to be happening tomorrow, so good luck with that. Remember, try to do your best. We are still going to be taking that exam in the afternoon, so just be aware of that. But next week on Monday and Tuesday, that's when we're going to be taking our TSI, okay, the math TSI. Hello, come on in. Okay, so not only tomorrow, but Monday and Tuesday of next week, you definitely want to go ahead and bring your charged Chromebook because there's not going to be paper copies. You're going to have to do it on the Chromebook. And we'll just talk more about the TSI on Friday. That's when we'll go ahead and start looking at that packet that I gave out yesterday. All right, so questions. Okay, sounds like a plan. All right. Okay, so let's go ahead and get started here. All right. So I went ahead and chose some problems ahead of time that I thought were going to work out very nicely for you. Carlos, take it. Okay. So let's go ahead and skip to number 2. Sketch the following systems of inequalities. Okay, so we're going to have to go ahead and create some axes, go ahead and plot these. So let's do like we did before. Let's say that this top one is 1. Let's say that this bottom one is 2. In fact, let me move that to the side so we can actually have a little more room to see. Now, for this one, it's kind of unusual. You're not going to want to put the axes in the direct middle. Just because of where the shaded region is, let me go ahead. I'm going to put the axes like right about here. Okay, so right there is going to be my origin. Okay. And again, you'll see why I did it this way in just a second. Okay. Now, the first one is already in slope-intercept form, so what's its y-intercept? -3. Okay, so if that's 0, -1, 2, -3, so there's my y-intercept. The slope is 1/2. So from here, I'm going to go up 1 to the right 2. Okay, so I'm going to go up 1 to the right 2. Now, I'm right on the edge of my grid, so instead of going up and to the right, I can also go where? I can go down and to the left. So down to the left, down 1, left 2, down 1, left 2, and I can keep going this for a while. Okay. Now, I'm going to go ahead and draw my line, but we've got to decide. Joseph, solid or dashed? Solid. Why? We have equality. Okay, remember, if we have this bar, if we've got equality, it's going to be a solid line. Okay, so I'm going to go ahead, put my line through here. Okay, just like that. Now, I like to go ahead and shade once my lines are drawn. Okay, if you want to go ahead and shade now, I mean, you're more than welcome to. Okay, so there's my first one. Now, what do we notice about the second inequality? It's not in slope-intercept form, so let's take some time to do that. So if 2x minus 3y is going to be greater than -6, well, the first thing I'm going to do is get rid of that 2x. So a -3y is going to be greater than a -2x minus 6. Now, what's about to happen? There we go. We're about to divide an inequality by a negative, so that symbol is going to reverse itself. So I'm going to divide through by this -3. So now it's less than. So y is less than. The two negatives cancel. That's 2/3 x. And then that's plus what? 2. Okay. So now you see why I kind of did it the way I did. So I'm just able to get this on the edge of the grid. So we have a +2 for my y-intercept. Now, this is telling me that I would go up 2 to the right 3. But I'm already on the edge of the grid, so let's just reverse it like we did a moment ago. Let's go down 2, and left 3. So down 2, 1, 2. There's a point right there. And then we can keep this going a little bit. So down 2, left 3. And right there, I'm already off the grid. Okay. So I'm going to go ahead and draw a solid line for this one too. Why? We don't have equality, so it's got to be what? It's dashed. Okay, so I'm going to go ahead, get my dash right here. Okay. Try to pretend that's a straight line. But they're going to intersect off the grid. Again, that's why I drew the axes the way I did. It's only this one that was kind of unusual. Okay, so this is going to be the second one. All right, well, now all we need to do is determine where my shading is going to go. Okay, so how does this work? Like for the first inequality here, y is greater than or equal to 1/2 x minus 3. What do I do? How do we know? There you go. Remember, if it's y greater than or equal to, we're going to shade above. If it's y is less than or equal to, then we're going to shade below. Okay, so for this one, I'm going to shade above the line. Okay. And then for the one in green, we ended up with y is less than, so I'm shading it where? Shading that one below. Now, what am I looking for when we have a system of inequalities? Yeah, we're looking for the double shaded region. Where does it overlap? Well, we're looking for this triangular region right here in the middle. That's where all my solutions are going to be. Now, what am I talking about when I say solutions? There you go. That's what we're looking for. Any ordered pairs where I go ahead and plug into both of these inequalities and it makes them true. All right. There you go. Easy, right? Okay. Am I looking at straight 100s across the board tomorrow? Kareem said it. He said yes. Okay. All right. Well, let's take a look. Let's go to 3A. So we're still looking at a system of inequalities. It says determine if the following ordered pairs are solutions to the system of inequalities. Okay. So all I want to do is plug these points in one at a time, but it's only a solution if it makes both true. Okay, so let's start with 1, 1. So we have an x and a y. So let's see here. 3 times 1 minus 4 times 1 has got to be less than 8. Well, is 3 minus 4 less than 8? So negative 1 is less than 8. Okay, so it makes the first one true. So we're off to a good start. Let's see what happens for the second one. So 2y minus x, so that's 2 times 1 minus 1 has got to be greater than or equal to negative 4. Okay, well, let's see. 2 times 1, 2 minus 1, that would be 1, is greater than or equal to negative 4. What do we think? Yes. So 1, 1 is a solution. Okay. There we go. And then you would want to just do the same thing for whatever remaining points you have here. Did we want to go ahead and check another pair just for practice? I'm thinking at this point everybody knows what to do. Okay. All right. Cool, 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 cool. Yes. Oh, even if they're different numbers, it could still be a solution. Okay. Well, for example, choose one. 0, 4. Let's go to the next one. Okay. So right now we're testing 0, 4. So this is now my x and this is my y. So let's go back to the original inequality. So 3 times 0 minus 4 times 4 has got to be less than 8. Let's see. 0 minus 16. So is a negative 16 less than 8? Yes. So it makes that first one true. We're good. Okay. So let's try the next one now. So 2 times y, that's going to give me 2 times 4 minus x. So that's just minus 0. Well, that's got to be greater than or equal to negative 4. Well, let's see. 8 minus 0 is 8, greater than or equal to negative 4. Yes, so that is a solution as well. So 0, 4. So you've only got 3 more points to check. Maybe they're yes, maybe they're no. That's what we got to figure out. That's easy, right? Okay. Everybody gets the point? Those are coordinates. Yeah. Yeah, thank you. Thank you. I appreciate that. Okay. So, Jabari, does that make sense? Okay. Cool, 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 cool. All right. Well, let's go ahead. Let's flip this to the other side here. Let's look at 5A. So there are several 3x3 systems on there, okay, that you're going to have to go ahead and solve. Now, 2 ways I've shown you how to solve these. You can solve them by hand using what strategy? Elimination, which you are more than welcome to use. Okay, but remember, you have to finish this within the class period. What was the other method? Now, I did show you substitution, but there is an even faster way. Inverse matrices. You're going to be allowed to use those calculators tomorrow. Okay, so let's take a look at this one. Bless you. 10x plus 7y minus 2x equals 46. 3x minus 2y plus 9z is 22. And 5x plus y minus 3z equals 28. Well, the first thing I taught you was to go ahead and rewrite the system as a matrix equation. So I'm going to start with the coefficient matrix. Bless you. So why in the world do we call it the coefficient matrix? Because it's made of what? Coefficients. So you'll notice our top coefficients, 10, 7, negative 2, that's going to be my top row right here. 10, 7, negative 2. Okay. So what's my second row? 3, negative 2, 9. And finally, 5, 1, negative 3. So remember, this is matrix A. We multiply matrix A by matrix X, the variable matrix. Well, I'm trying to solve for X, Y, and Z here. Okay. Now, once I multiply those, it's going to give me matrix B, which is my constant matrix. Okay, well, my constants, that's what these equal. So we got a 46, we have a 22, and then we have a 28. Okay. So that's the matrix equation. It's kind of coming back to everybody. Now, when I put this in the calculator, here's how I want to input it. I want to take the inverse of matrix A and multiply it by matrix B. Once I do that, it will immediately give me my solution. Okay. Now, we have to input these. Does anybody remember what the dimensions of A are, or what I'm referring to when I say that? 3 by 3. It's the number of rows by the number of columns. So A is a 3 by 3. What are the dimensions of B? So this is a 3 by 1. Remember, it's always the rows by the columns. Rows first, columns second. Okay. So let's go over to the calculator. Let's go ahead and plug these in. So I'm going to go to my calculate screen. Now remember, I'm wanting to use on the right side of the calculator, it's right below delete. I want to push this button that's right between 9 and the catalog, that open book. Okay. The second row has all of your matrix templates. So the first one we're going to need is the 3 by 3. Now remember, this is the one. If you have a different size matrix not shown, you can change it to whatever size you want. So we need to start with the 3 by 3. Okay, so let's plug in my numbers. I'm not going to remember those off the top of my head. So it was 10, 7. 10, 7, negative 2. Then we had a 3, negative 2, 9. And finally, I got a 5, 1, negative 3. 5, 1, negative 3. Okay. Now remember, we got to type in A inverse B. So to tell the calculator to take the inverse of this matrix, you're going to use your touchpad. Remember, you're going to push the right button because you want to get the cursor outside your matrix. See how it's outside my bracket? Now you're going to use this button here, the caret button. It looks like the top of a house. Okay. And in that power place, I'm going to put negative 1. So we're not going to actually see what the inverse matrix looks like. We don't have to. We're not interested in that. Okay. Now I'm going to go ahead and use that arrow key again. Okay, make sure it's not in the cursor. Times Now I've got to put in B. Okay. Everybody still with me? Okay, so I'm going to go back to this button right below delete. Now, this is a 3x1, so I got to go back to a 3x3, and I've got to change this to what I need. Okay, so I need a 3x1. Okay, and my constants were 46, 22, and we were looking at 28. Okay, so A inverse times B, I push enter, boom. Yeah. There it goes. Yeah, I don't know why I did that. That's weird. Okay, so I know that my order triple 6 -2 0. Okay, so this is 6 -2 0. Yeah. So anybody who wasn't able to pull that up on your calculator. Okay. Let's take a look. Oh, sorry, sir. Okay, so if you're getting weird ones like that, 10, 7, -2, 3, -2, 9. Aha, should be a 5, 1, -3. You got a 2 in there. And then 46, 22, 28, that's it right there. Okay, so that's also probably not a bad idea. Once you go ahead and get your matrices in there, take a few seconds, go back over and make sure the values are correct. If it's being subtracted, it's negative, all that good stuff. Okay. Okay, so let's see. Oh, I can already see one off top. See, you've got 10, -7, -2. That should be 10, 7, -2. Okay. So if you're not getting that solution, go back, look to see what value or values you need to change. Okay, questions on that? Okay, so one more problem I want to go ahead and take a look at with you. Okay, let's look at 6B. Okay, so 6B, it says, at a restaurant, Karen orders 3 tacos, 2 enchiladas, and 1 quesadilla, and spent $31.75 before tax and tip. Susie orders 1 taco, 3 enchiladas, and 1 quesadilla for $26.75. Preston ordered 2 enchiladas and 2 quesadillas for $18.50. So you're going to have a couple of problems on there where you either have to just write the system, or you're going to write the system and then you're going to solve it. Okay, so let's say in this case here that X is the price per taco. Let's say that Y is going to be the price per enchilada. And let's go ahead and say that Z is going to be the price per quesadilla. And I'm just going to go ahead and put quesadilla. There you go. And we always identify our variables. Okay. So here's what I want you to do. Take about 30 seconds. If you haven't already started, write me the 3 equations they're describing in the paragraph. Okay. That right there is half the problem. If you can successfully get the system written, well, then the calculator can take over from there. You're good to go. Even though you could solve this by hand. Remember, we've already seen examples before similar to this. It's perfectly fine if one or several of your equations don't use all the variables. There is nothing wrong with that. Okay, Is everybody about ready, or do we need a few more seconds? Okay, well, I'm just going to go ahead and write the equations, and then we'll talk about them if we need to. So for the first one, I got this, 3x plus 2y plus z is equal to 31.75. Then I got x plus 3y plus z is equal to, what was that second time? 2675. Okay. And then 2y plus 2z is equal to 1850, 18.5. Now remember, it's also very possible that you might end up with variables on different sides of the equation. Okay, you want to go ahead and put them in this form. You want all the variables to one side, you want the constants on the other side. Okay, yes?
So could you put these in like the inspired calculators as a matrix or something?
Oh yeah, absolutely. See, it's a 3x3 system, even though the third one doesn't have x. We're going to solve it exactly like we just did 5a.
You could put like, you could put 0 in place of that.
That's exactly right. Okay, so let's set this up. Let's create matrix A. So what's my top row? Okay, 3, 2, 1. Second row. 1, 3, 1. And now Jabari is absolutely right. If a variable is missing, you always want to go in order, like x, y, z. So there's no x, so I'm going to put a 0 there. And then I'm going to put 2, 2. This is matrix A. Okay, we're going to multiply this by matrix X. This is my variable matrix. So A times X will equal matrix B. This is my constant matrix. But my constants, 31.75. Then I've got 26, 75, and finally 18.5. So what's the expression that will immediately give me my answer? What do I have to do to A? We have to take the inverse and then multiply that by what? B. This is what you want. Okay. So let's see what we get. Let's see if we can all get the same thing. Coming back over here, I'm going to go ahead and clear this out because we don't need that on there. Okay. Where do I find the matrix templates? Okay, right below delete, next to 9. Okay. So the first one is a 3x3. Okay, it already says 3x3. So let's see here. We had 3, 2, 1. So 3, 2, 1. Then the next row was 1, 3, 1. 1, 3, 1. We didn't have an x on the last one. Remember, that's 0. And then we had 2 and 2. Okay. So I got my coefficients in. And I'm going to use my touchpad, get that cursor outside the matrix. Where do I go now? The caret button on the far left in the middle. Okay. 2 buttons away from 4. This is going to allow me to put in that -1. This is telling the calculator to find what? The inverse, okay, which we will not see. Okay. Now I'm going to make sure, very important, use your right arrow key one more time because you don't want to be inside the power anymore. So I'm going to hit times. And now let's put in the other one. Okay. So let's say here, go back to this. This was a 3x1. Okay, so I'm just going to change what I need. And now I'm going to put in my values. 31.75. Then I had 26.75. And then 18.5. There we go. A inverse times B. So when you push enter, here are the prices. Okay. So a taco should be $5.50. An enchilada should be $6. And a quesadilla should be $3.25. How many folks got that? Fantastic. Okay. These are the concepts that are on your test tomorrow. Okay. Anybody having a hard time? Anybody lost? Okay. Like I said, yes. You will be allowed to use the Inspire tomorrow on the exam. Okay. Now remember, this isn't a paper exam, so you have to bring what? You got to bring your charged Chromebook. Okay, please don't forget that. You'll also, again, want to bring it on Monday, Tuesday, because you're going to be taking the TSI math. Okay, but we'll talk about that again on Friday. Jabari.
Oh, are one of the teachers going to be disabled for the calculator?
Actually, all the Algebra 2 teachers got together. We disabled numerical solve and solving a system.
What's that?
There are features on the calculator where you could just take an equation, you could plug it in, and it will solve it for you. Or if you just type the system into your calculator, it will solve it automatically, but we disabled those. But the inverse matrix will still work. Okay. All right. Well, how are we doing? Okay. Are we feeling a little more confident for that test tomorrow? Hopefully. Okay. All right. Well, I'm going to go ahead and give you the rest of the time. Right now it's 2:54. We are out of here at 13. So you still have a good amount of time. Remember, I'm not posting the key until after school, but I would go ahead, start taking a look at these problems and seeing if you're having any difficulty. Okay. All right. So do your thing.